you solve this by looking without using calculator, express z in the form of r ei theta. Okay, there are a few ways of doing this now. First of all, r ei theta, you need the angle and the what do you call it, the angle to be the same. Now this is quite confusing, right? So some students would like to just separate it and then make it two complex number and then try and merge them. I don't really like that. I would rather use the double angle from MF26. So I'll show you what I mean by that. I like to use this one here. So you don't have to use this formula here. This is a factor formula. This factor here, okay? So it means you add both of them up. It'll be much easier for you. Okay, so you merge these two up. This is actually easier. Merge these two up. So we do this by merging them. So cosine 3/16 pi plus cosine 7 pi over 16 plus I sine 3 pi over 16 plus sine 7 over 16 pi. Later I'll show you another method of doing it, but that one is a bit lengthy though. So I don't know whether should I. Okay, so this one here, cosine plus cosine is this one. So it's 2 times the average and the difference divided by 2. So I'll just write that down. 2 times the average, which is cos, right? So this will be 10 over 16 pi over 2. I added them up straight. This will be cosine, minus of them will be minus 4 over 16 pi divided by 2. Oh my goodness, there's a minus there. Okay, I should swap the top because there's a minus here, right? So never mind, I'll just leave it there. Then you have got the sine. Sine plus sine is the same, sine cos. So this will be I sine cos is minus 8. Okay, so this is what you do. Now, just take note of this. Cosine negative theta is cosine theta, positive. Sine negative theta is actually negative sine theta. Okay, so we were going to use that obviously. So this one could be simplified to 2 cos 5 over 16 pi cosine 2 over 16, 2 over 16, 1 over 8. Um, 10. Okay, you see that? Take note, cos minus power 8 is cos power 8 because of this identity here. There you go. Okay, so any question, please ask me. Now, next, what do you do? I think it's quite straightforward already. So you need to separate and you need to separate and see how do you express this as the trigo form. The trigo form is actually this form here, right? Which is actually r cosine theta plus I sine theta equals to z. This is a trigonometric form. So you try and leave the sine with the I and bring the cost out. Okay, so factorize lah. So what I'm going to do is I'm just going to factorize the 2 cosine pi over 8. Okay, like that. This is one. This is part is important. Huh? Question. I'll just pause here for a while. Next part is basically this is your R. This one over here, just use EI theta. Right? So EI theta is equals to, this is a Euler formula here. Then this will be 2 cosine like that. Okay. That's how I do this part here. The last one is find the smallest positive integer value n such that this is some positive real number. Okay. So take note, this can be, this one, like I say, this ratio is 1:1. So you can find the exact argument. So in other words, now you want some positive real number. If you want some positive real number, means the argument has to be here. Okay, this argument will be basically 0 plus 2k pi. So the argument of that number, Zn, would be Zn, because the k would be some number which is actually 0 plus 2k pi. Just take note of that. The small is such that this one, oh, sorry. No, I interpreted wrongly. They want argument of Zn equals to this one, positive real k. No, they're referring to k, not the z, my bad. Okay, so you argument both sides, so you're actually not using this one. I interpreted it wrongly. So argument of Zn, because if you want this equals to this, what it means is this argument must be equal to this argument here. Okay. And since argument behave a logarithm, so this is argument minus 1 plus minus k I. This is n argument z. Now, whatever you put here, you need to put a plus 2k pi. Then I know a lot of you will ask why I need to put a plus 2k pi. Okay. The reason why you need to put a plus 2k pi is because you need to expand beyond the principal argument. So it means anything beyond that you need to consider also. So you just imagine like 360 out of the range, within the range, you need to add them up. So this is how you put it plus 2k pi. So argument and argument z we already have it. Argument z is this one here, okay, which is actually 5/16 pi. Argument k is positive, so this is 0. K is a positive number. So argument minus I minus 1 minus I is actually negative. All these you all have to know already. Minus 1, this is actually minus 3/4 pi. So this is minus 3/4 pi. And this is plus 2k pi. So once you've done this really, you can actually just take 16/5, 3/4 plus 2k. Simplify it. Okay. This is what you get in your question. Then you just key this into your calculator and hope for the best. Okay, so I'm gonna key this in the calculator. This is 16/5 times negative 3/4 plus 2k. Second table. Why so many words? Okay, here. Okay, so this is what I do. I just table value it. And what do they want me to do? the smallest positive integer n. So from GC, smallest positive integer is 4. Or you can just inspection. Inspection also can. Okay. You can inspect, you can okay, that's how you do this part here. This is k. This is your n. So this part is okay. That's how you do it. I think that below is okay. RJ, RI, okay. Okay. Okay, let's do the can? Is it okay? If it's so difficult, let me know.